Yes, I would like to start today's lecture with requesting not to be afraid to ask questions, and I must follow my recommendation myself. So I'm not afraid to ask you questions, and therefore I'm starting to ask you questions. That is a very strange way to start lecture, is it not? Okay, now we talk about buckling of such a column, and here there is this rotational spring, and there is this load P. Now, if you remember, we have here W equals 0 and EI, W second derivative, equals F times W first derivative. And here W equals 0, and EI W second derivative equals minus F W first derivative. And we did discuss the case that when F is 0, then we get actually W equals 0 and second derivative equals 0. So this is equivalent to simply supported end. And on the other hand, when F goes to infinity, then actually we can divide it by F, and we get EI W second derivative F equals W prime. And when F goes to infinity, W prime goes to 0. So boundary conditions are W equals 0 and W prime equals 0, and that is a clamped end. So F varies between 0 to infinity, and when at this end we have simple support, and here we have clamped support. Did we write this? Now, this is page 2. That means that we get actually the buckling load P critical will be then varying between 4 pi square EI over L square and pi square EI over L square. So that is this variation. I have several questions. Question 1. Can we get from the above case simply supported clamp column? Maybe I will start with another one. Clamped free column result. Or maybe I will, instead of result, I will say case. This is question number 1. Let us start first question from the left. Second question I will start from the right. And third question I will start this way, and then fourth that way. Okay, Ms. Gentilini. Okay, so she says, Ms. Gentilini said that clamped free column has P critical equals pi square EI over 4L square, and this pi square EI over 4L square That is belongs, yeah? She says does not belong to this interval pi square ei over L square 4 pi square ei over L square. Does not. So what is your answer? That we know that this does not belong to that interval, but what is an answer? Can we get? My question was, can we get? Say yes or no. No. So actually when she says no, and what she means actually is as follows. Look, please. That is this figure, yes? When f is 0, we get pi square ei over L square. When f goes to very high value, that is 1, 2, 3, 4, then it goes here. So imagine that, so it should go here somewhere, and it starts here. And that value, which we talked, this one is here. Okay, 1/4. So that is here somewhere. So that is this value. So no means that she says that variation will be, say, like this or like that. So will be a monotonous variation. That is what her assumption is. Because if it was non-monotonous, then it would be behaving like this. So that is pi square ei over L square. This is 4 pi square ei over L square. That is this 1/4. So she says that there is no behavior like this, for example. Okay? No behavior like this. So what you actually, and I hope that your calculations, you did perform calculations, is it right? And your calculations actually should give an answer. I think that what was a result of calculations, Mr. Gomez? Did you get curve like this or curve like that? That is 1 or 2? You did not do? Mr. Placencia? You did not do the calculations? That is what I asked you. I asked you to do calculations. What about Mr. Andres? Did you do the calculations? That is why I assigned you to groups, because group does easier calculations. I did not assign you groups just to discuss the matter, just to have, so to say, a verbal communication. I wanted you to have some computer communication. So it is closer to 2. I see, okay. Mr. Andres maintains. What about Mr. Penteras? Did you do? It's closer to 2 or closer to 1? 1. Okay, so that's very interesting. So Mr. Penteras, PA, yes? And that is Mr. Andres. So it's very strange. That is like, now imagine that there is an accident in the street and there are 2 witnesses. One witness says that this happened like this, and second witness says that it happened like that. So this should not be in the buckling course. In the buckling course, you know, you remember there is this, I think, there is this movie, Japanese movie. think Rashomon is called. There is some event described by, the same event is described by 4 different people. And 4 accounts are very, very different from each other. So how that can be? Of course, it could be. I mean, at least I will find you one possibility that could be. Look, please, 4. If there is this figure like this and figure like that, then if you are using a very pen that has very big, like brush, so to say, then that's the same, so to say. Okay. And these 2 are coinciding with that region. And then these 2 accounts are more or less the same. But I think that in backlink probably it's different. We will see later. Now so we anticipate clamped free not to be the subset of this problem. Another question is Q2. Can we get, or how to get, the case simply supported clamp, say by modifying this problem? Can you modify this problem and get a simply supported clamped case? Please think a few minutes, and I will walk through you. I mean, in the limit, whether we can get. How to get the case simply supported clamped in the limit. Add here the words in the limit by modifying this problem. How to change this problem and get as a possible result simply supported clamped. F1 and F2.
Oh, yeah.
But you cannot. Yes.
Don't have
I don't want homework. I want to see. I want you to answer this question now. I don't want you to look at the homework. So you should make a finger and. So some people did give an answer, and I will reproduce that answer. One answer is like this, that both gave this answer. So answer 1. Okay, so this is P. And here they introduce spring F1 and here spring F2. And then they get EI W second derivative equals F1 W prime. And here is EI W second derivative equals minus F2 W prime. So we want to get what? Which case? Clamped simply supported? Simply supported clamped. So if we want to get simply supported clamped, we want then F1 should go to 0 and F2 should go to infinity. Okay? So that is possibility number 1. Now there is a simpler possibility. We want simpler possibility. And that is to make here simple support. And here make a spring. So here W equals 0, W double prime equals 0, and here W equals 0, and then EI, W second derivative equals minus F W prime. Just to have that there. Okay, here, because we want to have simply supported clamped. So clamped we will obtain when F will go to infinity. So here then, it will go like this. The buckling load will go, that is P critical, from pi square EI over L square. And that is 2 pi square EI over L square. And that is F. This is 0. When F is 0, so we have like this, like that. And for how much do we have for simply supported clamp? What is our exact result? $20.16, is it right? So it's a bit above that. Figure will be like this. So I would like you to consider this as a homework. This is the homework assignment. This is a homework assignment if your Social Security number ends with and what do you want? How many people have odd number at the end of Social Security? And how many even? You have even or odd? Okay, decide. What is the number at the end? Odd. Okay, then odd number. And this will be done if Social Security number ends with an even number. Just majority, I gave simpler problem. Minority, I gave more difficult problem. But in the future, I will change. I will change this. It will be different so that we will have a balance. Okay, so but we would like to, we should get graphical results. And get numerical table. Remember we introduced here, we should introduce what? Alpha 1 equals F1L over EI. And here will be alpha 2 F2L over EI. Here will be just alpha that equals FL over EI. And I do recommend these three people to get together, or at least you can correspond by email. And these people, so Mr. Berezhnoy, who is not here, but who hopefully will watch this video, and those who are not here, please do this problem. Okay? Any questions? Okay, if no questions, we will proceed. Do you have any questions about the problem? We should get the numerical results also. Now, another homework will be 4 and 5. Check critically every step in example 32 on pages 418 and 419. Any questions? Now we would like to move to the next subject, which is on page 422. And that is differential equation of second order. So imagine that is 422. We are dealing, imagine that EI is constant. Then differential equation is EI, W fourth derivative, plus PW second derivative equals 0. Now we can integrate this, and we get EI, W third derivative, plus PW first derivative equals A. This is one integration. Then we integrate again. EI W second derivative plus PW equals AX plus B. So we can get second order differential equation. But A and B are constants of integration. Okay? Now that is written in equation 135. A and B are integration constants. Now, if the column is simply supported, let us look what happens for the column that is simply supported. If the column is simply supported, for x equals 0, x equals 0, w equals 0, and w second derivative equals 0, yes? So let us substitute into this equation star. We substitute x equals 0. Now, EI w second derivative plus PW. This is 0, and this is 0. A equals AX plus B. This x is 0. So what is left then? B must be 0. B must be 0. Now let us write at L, at x equals L. We have the same equation. We will write the entire differential equation. EIW second derivative plus PW equals AX, AL. P is 0 already. Now this is 0 and this is 0. So what do we get about A? 0. So that means that if this is a simply supported B column, then we get this differential equation. EIW second derivative plus PW equals 0. And now, otherwise, the differential equation should be of the fourth order, so we should write it down. If the beam is not simply supported, then we cannot possibly use all these considerations. And differential equation should be considered of the fourth order. Now we will jump from here. That is page 5, 6. Immediately we will do some jump. I should have prepared 10. Okay. And let us undo that. Complicating effects. We will go to consider some interesting case. But I have to find that case before. And we will search for that case. Yes. And that is on page 7.1. Instability problems governed by differential equations with variable coefficients. This part is written very long time ago, as you see, in April 24, 1995. Since then, I did not come back to this chapter, because when I'm teaching actually selected topics. I do not teach entire thing every time. So I did not make any corrections since then. But this example belongs to someone whose name is Duncan, from United Kingdom. And he says as follows. Let me just illustrate what he says. He says, consider simply supported column. Imagine that modulus of elasticity equals 4x L minus x, L square times I0. Now what is this? That is this function, I of x. That means that when x equals 0, I of x equals 0. When x equals a, I of x equals 0. When x equals 1/2, L over 2, sorry, we will get 4 times L over 2, L minus L over 2, divided by L square. So that is what? 4 times L over 2 times L over 2 divided by L square. This is 1. So I of x equals I0. So what is I0? I0 is moment of inertia in the middle. So this looks like this, and the beam looks like this. This is an axis. That is such a cross-sectional area. Okay? And the load is like P is here. And entire thing is simply supported. Okay, the length is L. So here, moment of inertia equals I of L over 2 equals I0. Moments of inertia here are 0. Seven. Okay, did we write all of this? 8. Then Duncan says, okay, how differential equation, ODE, ordinary differential, or governing differential equation will be EI0 4x L minus x over L square d2w dx square plus pw equals 0. Now I have questions, innocent questions. Can we substitute W equals A in power Rx to solve this equation? This is an ordinary differential equation. Mr. Penteras. I'm coming now from right to left. I started from left to right. Okay, answer. Yes, we can. What do you think, Mr. Plasencia? So that is beta, I don't know. Gamma. At the end, we will decide by majority. Mr. Andres? Why? No constant coefficients. Despite the fact that this person is minority, he is right. Okay? So we do not actually decide by majority, naturally. I'm not continuing further because we found the truth. No, we cannot do that because there are no constant coefficients. This coefficient varies with x. Only if the coefficients were constant, we could have substituted such a thing. So W equals A in power Rx does not work. Okay, naturally it does not work. Why? Please. If I would substitute, then I would get, look, ei0 4x L minus x L squared. Then it will be a, second derivative will be r squared in power rx plus p a in power rx equals 0. This would cancel. A we don't need. But then r would depend upon x. Okay, but we stipulated that r is constant. So therefore this does not work. So what should we do? Miss Gentilini. Question, what should we do? Speak louder. We don't have to use this, but what should we do? Okay, substitute something else. What, Mr. Andres? Yeah. So actually, there are no general rules to solve ordinary differential equations with variable coefficients. So I don't know, it's a very good answer. Actually, there are no general rules. So, however, Mr. Duncan had a revelation. I mean, he said, let us substitute something else. As Miss Gentilini said, that something else should be substituted, but she did not know what. So Mr. Duncan did know. He said, let w of x equal 4x L minus x L square A. That is what he says. I am guessing that is what he says. So he guessed the solution. Now you can ask, what does it mean he guessed the solution? How did he guess the solution? I don't know how he guessed the solution. He said, I, Duncan, say that w of x equals this function. Mr. Duncan. Okay, that is what he said. So let us check now. Maybe this suggestion is good, maybe this suggestion is not very good. So, w of x equals 4x L minus x L square A. Okay? So, or w of x equals, look what? 4xl minus 4x squared over L square A. Let us calculate first derivative. Will be, derivative of x will be 4xl will be 4L minus 8x divided by L square A. Now second derivative. This gives 0. This gives minus 8 L square A. Now let us substitute in the differential equation. That is what? EI0 4x L minus x L squared W second derivative plus PW equals 0. We substitute this w here and second derivative here, yes? So we get ei0 4x L minus x L square. Second derivative, minus 8 L square A plus PW 4x L minus x over L square A. Now, A and A can be cancelled. Look, 4x L minus x L square here and here also can be cancelled. So what is left is this equals 0, okay? I forgot this equals 0. So we get ei0 minus 8 L square plus P equals 0. How much is P from here? P equals 8 ei0 L square. Oh, I said that this belongs to Duncan. That is not correct. This example actually belongs to someone else. I made a mistake. This example belongs, it's not written here, I found Zhanitsin. Zhanitsin, 1955. Okay, P equals 8 ei 0 divided by L square. Not Duncan. Or Duncan. Duncan has another example, which is equally striking. A Duncan example. He has as follows. I of x equals 1 minus 3/7 x over L square I0. Now this example is a bit better, I suspect. Why? Because when x equals 0, I of x equals I0. So I0 is moment of inertia at x equals 0. When x over L equals 1, I of x equals 1 minus 3/7. That equals 4/7 I0. So that means that this starts like this. This is like this. So 4/7 is a bit bigger than 3.57, which is half, so a bit more. Something like that. Okay, and that is simply supported. You see, Zhanitsin had I equals 0 at x equals 0, x equals L. Duncan has no 0 I of x. Nowhere, it does not become 0. Okay? Now Duncan says, he also guesses. He says, okay, first of all, differential equation will be. Differential equation. ei0, 1 minus 3/7 x over L square, W second derivative, plus PW equals 0. That is his differential equation. Now he guesses W equals A times 7x over L minus 10x over L cubed plus 3x over L fifth power. Now let us check. First derivative equals A 7 over L minus 10 over L cubed 3x squared plus 3 over L in fifths, 5x in fourth power. W second derivative equals A. This term vanishes. This term gives minus, now will be 6, so will be 60 over L cubed times x plus, now will be 4 times 20, 4 times 5 will be 20, 20 plus 20 times 3 is 60, L in fifth power x cubed. That is a second derivative. So we substitute this there. So we get EI 1 minus 3/7 x over L square. Second derivative, so it will be A. 60 can be taken out. Yes, 60 will be minus x over L cubed plus x cubed over L in fifth power. That equals plus P W. W itself, I'm just writing down, A equals 7x over L minus 10x over L cubed plus 3x over L fifths. That, let us check this now, whether it equals 0 or not. This equals, I'm multiplying. So I will take out also this L cube, okay, because then we get 60 EI L cubed. And we will have now, I will multiply by minus x first, minus x, and plus 3/7 x over L squared times x, so that is this term. Now I'm multiplying this one, plus x cubed L squared, yeah, because I took L cubed. And now here will be minus 3/7 x cubed, so will be x in fifth power. There is L squared and there is L squared, so L in fourth power. Okay? Do you agree with this? Now we get this equals. Let me just deal with the first term only. Okay, first term. That is first term. Now we get 60 EI over L cubed. And that is we will write here 2 and introduce L inside. It will be minus x over L. Plus will be then 3/7 x over L, and there is x over L, will be x over L cubed. Yes? Then there is another x over L cubed, plus x cubed L cubed. Yeah, because I introduced one L. And then will be minus 3/7 x over L in fifths. Now these two terms together, that is 3/7 and that is 7/7. So will be giving me 10/7. So what I'm doing is I will also take out minus sign. will be minus 60 EI over L squared. So it will be x over L minus 10/7 x over L cubed. And then it will be plus 3/7 x over L in 5th power. That is what I got. Now I have to add the second term, yes, this term. So I will finish this as if. Okay, I finish there, and I'm writing now plus, that is A also here, plus PA 7x over L minus 10x over L cubed plus 3x over L in 5th power. We don't know whether this equals 0 or not. Now we can write down this equals minus 60 EI. First term I'm rewriting L squared x over L minus 10/7 x over L cubed plus 3/7 x over L in 5th power A plus, I will take out this 7, 7 PA, this 7 I'm taking, x over L minus 10/7 x over L cubed plus 3/7 x over L 5th. And now we see that this term and this term are the same. So we can write down as follows. That equals minus 60 EI over L squared plus 7 PA, and then is x over L minus 10/7 x over L cubed plus 3/7 x over L in 5th power. This can equal A because this does not equal 0 anywhere. Yes, because that is x of, yeah, except at 0. So not everywhere it equals 0. So if this is 0, then it's okay. So P equals 60 over 7 EI over L squared. If P equals 60 over 7, yes, EI 0, EI 0, everywhere. Then everything is okay. Okay, that is what was obtained by Duncan. So 2 people, as far as I know. Zhanitsyn, 1955. Duncan, 1937. Guessed the exact solution. Comments, questions? Mr. Gomez, do you have any comments?
IO is a moment of inertia in the middle of the beam.
I sub 0 is a value, yeah, in the beginning.
Does that mean critical buckling will occur at that point?
No. Buckling means that, no. Okay, question. Where does the buckling occur? Everywhere, because look, that will be a function. Yeah, there is some function which equals x 7 x over L minus 10 x over L cubed plus 3 x over L in 5th power A. and that is W. So buckling occurs, there is this non-zero displacement, so everywhere it occurs. So to say, if I can say everywhere, entire column is buckling. But this is the question. Okay, questions or comments? Mr. Andres.
Is this two different peak criticals for two different kinds of columns?
Yes, of course. Question. Two different peak critical for two different columns. Yes. Of course. Yes, they're not close. One is 60 over 7, and the other is 8 EI O over L square. So one is 8 EI 0 over L square. The other is 60 over 7 EI 0 over L square. It's two different problems I solved. Naturally, two different problems have two different answers. It could happen by chance that two problems have the same answer. For example, say, make a problem which has an answer 4. It's 2 plus 2 equals 4. 3 plus 1 equals 4. 5 minus 1 equals 4. 2,000 minus 1,996 equals 4, etc. In this particular case, we obtain different answers. Comments, questions, please.
I was going to talk about that as well, because
About what?
about how close we get the peak critical, because one is 8 but the other one is 8.5. So
Okay, somehow this particular student also wants to compare this, but I don't think that it makes sense to compare two different problems, because I0 here is in the middle, in the beginning. Here I0 is in the middle. So these are totally different problems. But comments, do you have any comments? Ms. Gentilini, any comment?
We have only one kind of, for this differential equation, we have only one kind of solution.
For this differential equation, we have only one kind of solution. You mean which problem do you talk, number 2 or number 1? No, solutions are different.
Yes, I different. If I change the solution, not the critical, the representation of the displacement.
No, she is asking, can we change W of X? What is an answer, Mr. Panteras? Can you change W of X? I think that we cannot change by no means W of X, because if I guess the exact solution, that means that that is an exact solution once I checked. And if it is an exact solution, means that any other solution is not an exact solution, and therefore it will be nonsensical to substitute anything different from exact solution. That, thanks heaven, is an exact solution. What is a comment? Do you have any comments? More comments.
I wonder how many times they tried to find that exact solution.
Say it again. Can you repeat your question?
How many times did they attempt a solution of WX before they found one that worked?
How many times did they try to guess W of X? What is an answer, Mr. Panteras? I think you will have the best answer. What is an answer to this question? Oh, It's very surprising. Mr. Panteras usually says correct answer. I don't know. That would be the correct answer for this case. But somehow he did not use this answer. Because how would we know? I mean, the only person from this group would be me if by chance these people wrote down. You know, if Zhanitsin would have written, I was sitting in the library and tried 200 times or 120 times. And if he would have written then in his book, then, because by chance I read that book, then I would be able to tell you. But I must tell you that none of them said, you know, neither Zhanitsin nor Duncan. They did not say how long they or how many times they tried. So therefore, I don't know is the best answer to this question. Okay, any other comments? Are these solutions nice, good, bad? You don't care? Mr. Gomez.
Are they nice?
Yeah. Okay, let us concentrate. He replied, Mr. Gomez actually repeated, are they nice? Let us concentrate on this word nice. Are these solutions nice? And from what point of view, if at all? If they are nice, okay, I will put back the solutions. These are the solutions. Are these solutions nice? Okay, that is a good suggestion. Mr. Gomez said that we should compare with something. Okay, do it. Compare with something. With what to compare, Mr. Plasencia?
Okay, I will try to answer the question.
No, now you have to answer. He said it was nice or not nice in comparison with something.
These big criticals have been determined, using origin function of I, moment of inertia. But just for that bit, or for that column, has been determined what happens if we have the same conditions but different material or different dimensions. Would that apply?
No, okay, he's asking, Mr. Plasencia is asking what happens if dimensions will be different. Look, if L will be different, you substitute new L and you will get different answer. If E will be different, you substitute this another E, you will get another answer. If I0 will be different, then you substitute it and you will get, and the answer will be 8 times EI0 over L squared. Or in this case, it will be 60 over 7 EI0 over L squared. If you find that these solutions are nice, then from what point of view, as Mr. Gomez most correctly pointed out, if something is nice, you should define criterion of niceness. Okay. Okay. Answer. Simple. What do you mean by simple? Okay, she said that they are simple because we have to know material, moment of inertia, and length. But we understand that, look, there is nothing else to know. Because when we wrote differential equations, there was E, there was I0, there is L. So there is nothing else to know. There is no possibility to get anything else as an answer. I mean, they will, E, I0, and L should be appearing in any solution. So therefore, it is, she says that it is simple, but why is that simple? So now we get actually a question, why simple and why nice? Actually, now we have two questions actually. So try to answer one of these at least. Yes, I agree that there is some simplicity and some niceness here. See, what happens most unfortunately in the university very often, that when people are coming to the university, they are curious to find something new, something totally different. They are excited. But we most unfortunately often succeed in the university to suppress this excitation. And then person becomes unexcited person. And what I'm trying to do is to excite you or re-excite you back. I would like you to get excited with what we get. But we cannot possibly get excited if we will not think. Okay? So we want to stop and think. What did we obtain? Simple, nice. Okay, but let us come back actually to Mr. Gomez's wise recommendation to compare this with something else. With what we can compare these solutions?
With the column with the cross-sectional area.
Yes. We can compare with I of x is constant. And their solution will be pi square EI over L square. So we have, look, we have now three things, okay, three different solutions. 14. Euler, pi square EI over L square. Zhanitsin, 8 EI 0 over L square. Duncan, 60 over 7 EI 0 over L square. 1744, 1955, 1937. Okay, let us compare now. Which solution is nicer out of these three? Oh, you don't? Please show this picture. Yes, thank you. Euler's solution is there, Zhanitsin's and Duncan's. Which solution is nicer? Okay, let us start. For example, I prefer, out of these two, I prefer Duncan's because I of x is not 0. Okay, out of these two, I would prefer Duncan because I of x never becomes 0. Because I of x is 0, if moment of inertia is 0 there, how do we hold actually? How do we do simple support, one could ask. But, okay, so the question is, which one is more interesting, this one or this one, from niceness point of view? Come on, get excited. Get awakened and then excited. Because if you are asleep, then you cannot get excited.
I have a comment.
Yes, please, make a comment.
You can see that three different columns has more or less the same behavior of the column with the cross-sectional area constant.
Say it again.
You can see that the three columns have more or less the same behavior.
Okay, she says that, Ms. Gentilini says that these three columns have more or less the same backing load, so to say. Pi square, approximately 10, here is 8, here is 60 over 7. Okay, so it's 9, something like that, less than 9. But okay, but that is so. We asked the different question, which is nicer and why. This does not suggest us any niceness or not niceness. Mr. Penteras. Euler's is nicer. Why? Because it's old. You like old wine. Oh, pie. Okay. Mr. Pantera, student 1. I like pie. Of course, he means piece of pie, yes? Piece of pie, then it would make totally understandable. So he likes pies. So he thinks that, Euler's is. So, okay, any other ideas? Other inputs?
It's interesting that the Duncan has almost the same critical or a theme that tapers quite a bit.
Yes, that is correct. But it is less than. Yeah, not much. But we are not going now to enter into numbers and this. We are talking about niceness. Okay, Mr. Pantera said that you like pie. Why do you like pie? Okay.
It would take less computer time.
Say it again.
Duncan might take less computer time because it's not working with an irrational number.
Can you repeat? I did not hear well.
Just saying that Duncan won't take as much computer time because it's not dealing with an irrational
Yes, Duncan will not take that much of the computer time because does not, let me give me a couple of minutes, deal with irrational numbers. So here he has two statements, of course. Duncan will not take much of the computer time. This we don't care. I mean, computer time, we can do some other work and computer can work. So that is not that important. However, more important is that Euler's is an irrational number. So this number is this is an exact solution, but it cannot be ever exactly calculated. Is it right? There is no exact number that. Now here, Duncan and Zhanitsin have very beautiful things. These are rational expressions. 60/7. Here is 8. These are rational numbers. Euler's is an irrational number. Thank you.